So this video is going to cover the output section of the main controller circuit board. Now this is the same circuit board that was in that control panel junction box I showed a while ago, except this area was at the top of the board. The top was going on top, and this was at the bottom. But as I have it turned this way, this is normally how I'd work at it on my desk. And I have diodes hooked up, LEDs hooked up to the output of this, so I can see what the software is doing. And I have switches and so forth, and other frequency generator or whatever hooked up to these inputs of the board. So, but in this video, I'm only going to be discussing this half of the board, these parts. So, anyway, so now all of these here, these are signal relays. They are 2 amp, maximum of 2 amp, non-latching signal relays, and they can drive small loads. They can, now the power relays out in the junction box outside in the well house, their coils only draw about less than 1/4 of an amp, so these can easily handle that load. So these are each 2 amp, and they're driving 1/4 amp loads, so not a problem. And also they're protected by some fuses in the junction box over there. So, and these relays are driven by these 3 driver chips. They are L293DNE driver chips. They can drive small motors, small solenoids, small inductive loads. And by the way, there is no, I'll just show you the diodes that protect against the inductive kick from driving the coil voltage on these. They're built into these chips. So these those diodes are also called freewheeling diodes or snubber diodes. And anyway, they're so I don't have to have them on the circuit board here. They're integrated into these, in each of these. So all the ports are diode protected on the outputs. All right. So let me show you the diagram of these chips, of the little relays here. All right. So as I said before, so I'm going to get a pointer here instead. All right. So pin 1 and pin 8, these 2 are across the coil, the input coil for this relay. And we normally would connect 8 to ground, and 1 will be either the input. This 1 is the input, and it'll either one will either be a ground or a positive volt. In this case, these relays here are designed to have a 12-volt input. So input will either be ground or a positive 12 volts. The output of this relay is on pin 3, and its connection will either be to pin 5. If 1 has a positive voltage, 3 will be connected to 5. If 1 goes to ground, then 3 will be connected to 7. Now this is kind of awkward to view, so I'm going to show you the actual layout of the PCB. We're going to zoom in here. Let's look at like this one right here. This one right there. All right. Zoom a little more. Okay, so as I said before, so pin 8 and 1, these are the 2 coil inputs. 8 is grounded, and pin 1 will go to either grounded when it's turned off, or it'll be positive 12 when it's turned on. And when this is when this relay has a grounded input, or is 0 volts, then 3 will be connected to pin 7. In this case, 7 is grounded. I have it grounded. If 1 is driven high with the positive 12 volts, then 3 will be connected to pin 5, which is 12 volts. And so when this has a 12 volt coming in, it'll pass the 12 volt to 3. Now to get an image of this here, this is the 12 volt input to the board. So you see how that, oh, by the way, you see how we have red and green? Well, red, everything that's red is on the top of the board. Everything that's green is on the bottom or the back side of the board, just for reference. So anyway, so you notice how we have 12 volts coming to pin 5 of all of the relays, right? See that? And all of pin 7 of all these relays are grounded. So, and inputs on all of them are pin 1. So let's follow this back now to the driver chip. This is the driver chip that's driving it. So pin 1 of this one, if I'm following it back, it's connected to pin 11 of this L293 DNE driver chip. Okay, so pin 11, and to find out what pin actually drives the input to the driver for this pin 11, we can look at the okay. So 11 is driven by pin 10. See that? And by the way, you notice how we have this enable here, this 1-2 enable. What it means is pin 1 actually enables the input from 2 and 7, whereas 9 enables the inputs from pin 10 and 15. So if we look at the schematic, or not the schematic, but the board, let's look over here for that DNE. Look back, zoom out a little bit. Okay, you see. Okay, so now this here is a 5 volt. See, this is the 5 volt input across a 10K resistor, pull-up resistor, and it's actually pulling up pin 1 and pin 9. See this? So it's always enabled. Everything's all, and it's enabled by this pull-up resistor here. And now we found, remember, pin 11 now comes from pin 1 on this, the input for this relay. It comes from 11, and 11 is driven by pin, it's controlled by pin 10, and pin 10, we follow it down, it's 10 is connected to pin 33, or port 24 of the propeller microcontroller. So if the propeller controller wants to turn the relay on, it'll put a high on port 24, which puts a high on a positive on port pin 10, and the output, and that switches on the 12 volts to pin 11, which comes to this relay here. This goes to 12 volts, and this switches from the ground to the 12 volt side, and connects that out to the relay. See that? So okay, that's just kind of a quick overview, but that's the basic size of it here. So these relays, once again, they're single pole double throw non-latching signal relays. All right, so that's it for this thing. Okay, by the way, each one of these drivers can drive 4 relays. This one drives these 4. This one drives these 4, and then this one right here drives these 4 down the bottom here. All right. So anyway, all right. So let me go back to the image of the board again. So now it's kind of more obvious what's going on, huh? See that? So okay. So that's it for this video. The next video, I'll discuss the input section on this side using the optical isolators. So, okay, I'll continue on the next video.